Hi everyone, I'm Jason Sheldon from IDA. I'm not Matt Avery, as it says in your handbook. Today I'm introducing to you Mr. Boris Chernis, Research Associate at IDA, been here since 2020. Boris has 2 Masters of Science degrees from the University of Houston in Physics and Computational Science, Computer Science. Is that not right? You're giving me a weird look.
Yeah,
Oh, okay.
close enough. Yeah.
Close enough. Okay, I'll take it. Before IDA, Boris has worked several different STEM-related positions, doing a bit of everything from optimizing seismic data processing to web application security. So today he'll be giving a mini tutorial on advancing reproducible research. I'll be in the chat if you're on Zoom, fielding questions to Boris if Matt doesn't answer them. Matt probably will also be in Zoom some.
Okay, so what is reproducible research? So anytime we conduct, anytime we conduct any sort of research or analysis, we want to make sure that we are maintaining continuity over the course of the project. What does that mean? It means that, well, first of all, anyone familiar with the project should be able to reproduce that research. And secondly, a researcher who is unfamiliar with the project should ideally also be able to reproduce it on demand without too much trouble. So basically, same data plus same methods equals same results. And by data, I'm talking about like the original inputs. So we have to have a way of preserving those. Uh, Methods, any type of analysis approaches, tools, scripts. Uh, yeah, so same results. By results, I'm talking about figures, tables, and conclusions, right? So those must be reproducible. Reproducible versus replicable are actually slightly different terms. So we have our input data, we have our workflow, and it gives us some results. So reproducible research means that if we take the same input data, right, apply the same workflow, we get the exact same results, even if it's done by 2 different researchers. Replicable is a similar concept, except your input data might be different. But if you apply the same workflow, you'll get a result that's probably not going to be the same, but it will be consistent. Okay, levels of reproducibility. Um, so the lowest level of reproducibility means that like you yourself can come back later and uh, and reproduce it. A slightly higher level, um, excuse me, is someone who is on your project team, right? So I mean, they're not going to be as familiar with your research as you are, obviously, but they're still going to be somewhat familiar. An even higher level would be a different analyst who is kind of familiar with the context, might have some subject matter expertise, but is on a completely different team and does not know the specifics of your project. And the highest level of reproducibility is someone who is like entirely unfamiliar. Like he probably works in a different field, but he should still be able to uh, reproduce it. And another way to think about it is how long in the future will you be able, like how far into the future will you be able to get a reproducible result, right? So, um, I mean, can you reproduce it tomorrow? Can you reproduce it next month? Well, what about next year? What about 10 years from now? Right? So that's another way to think about it. Um, and, uh, and and a third way to think about it is what do we like what does a researcher need to do in order to reproduce your result, right? So if they're just handed essentially a black box, then well they may need to reverse engineer it to like even figure out how it works. Um, uh, a much better approach would be like if they were given like a set of steps to follow and they had to like manually follow them. Um, Better yet is if the steps are all like you have it in source code, right? So it's all scripted. So as long as they're able to like set up their software and their environment correctly, I mean that they should be able to run it. But that still might require some like a little bit of expertise. And the highest level of reproducibility, sorry, is if they can literally just push a button and get the same result, because that requires like absolutely no like no skill and no effort. Benefits of sorry, benefits of reproducible research. So one benefit is that reproducible analyses are more credible and defensible than non-reproducible. So you're always going to be able to answer questions like, well, where did this number come from? Um, Another benefit is that they like it's easy and quick to make minor changes. So in this example, we have a box plot, and let's say that we want to change its color and remove this outlier over here. If I mean, if this were created in something like Excel or JMP, then like then that might require a little bit of work to accomplish. But if let's say you have it in a script, then in that case, that could potentially be a lot easier because all you're doing is you're changing this line of code from blue to red, and you're adding just one line of code saying that like uh, filter, make sure the distance is less than 100. So anything above 100 will just get removed. And this is R code, by the way. R is like a popular language for statistics and stuff. Okay. So reproducible analyses are less prone to certain types of errors. So hand jamming, like otherwise referred to as typing, is error prone. At some point, I was on a project where we were helping the VA modernize their electronic health records, and part of their workflow was something that they called the swivel chair method. And what that means is that whenever they had to transfer data from one IT system to another, they would have an employee sit on a swivel chair, right? And so essentially, he would look at one computer screen and then turn around and type the data into another computer screen, right? So that's an example of something you don't want to do. Um, and and if instead of a script you have like just a series of written instructions, uh, I mean, people sometimes forget steps or follow instructions incorrectly. So it's definitely better than just having to like type everything in from scratch. But still, it's not ideal. Um, Reproducible analyses make it easier to double check your work, to double check and review your work. So from that standpoint, like if you have it written as a script, then it is easier to double check uh, source code, right, than to redo your calculations from scratch. Because when you're, I mean, if you were to just like compute it on a calculator or something, then you're not going to remember everything that you like typed into the calculator. But if you have it in a script, you can always see exactly what you've like all the steps that you've done. And also teammates and like tech reviewers can uh, quickly understand your approach just by looking at the code. Okay, so let's talk a little bit about uh, data. So, excuse me, data management. Data management, it's really important. I actually have no idea which movie that's from, but Zoolander? Okay. Um, okay, so uh, data management should be set up in a way that it complies with with existing policies. So these bullet points are actually from it's from like strategy.data.gov. So they have like a federal data strategy uh, framework, right? So you want to like promote transparency, anticipate future uses, you know, like practice accountability, prepare to share with like other government organizations if necessary, uh, like effectively and efficiently convey insights from the data. You want to keep an inventory of your data assets and you know maintain documentation, right? So these are all reasons why like a robust set of data management policies is important. Okay, and some questions that it should answer. Where does the raw data live? Um, and where does the process data live? Uh, do does the data need to be stored securely? What tools are you going to use to manage your data? And what about things like uh, yeah, like uh, different versions of the data and of the data analysis. So this is like a very simplified workflow of data processing, right? So you collect your data, you process your data, uh, and then you analyze, and then you report. And this is often iterative. So by data collection, what do I mean? Well, it could be anything from just receiving raw data from your like client or sponsor to in some cases you got to go out there and do web scraping, which is where you like write scripts that like automatically download like data from different websites. Um, as far as processing data, it could be anything from like cleaning to formatting. Uh, you know, doing some type of like mathematical processing, and also like storing it. Whether it's like in a CSV file or like a SQL database or whatever. Um, and analysis, it could be anything from statistical analysis to various types of visualizations. Okay. Metadata is important, right? So metadata essentially means just data about data. So like common examples would be just a simple example of metadata is, if you're in your like file explorer, then like the title, size, date created, that kind of stuff is those are examples of metadata. But I mean, you could also have it in spreadsheets. So yeah, so any information about data that may be relevant is probably worth keeping track of. Um, and we should also ensure that the data are available in a non-proprietary format, if possible. So, uh, like if it's encoded in some weird way, and if it can only be opened by like very specific software, then it might not be usable uh, to anyone who's not willing to pay for that software. So, like a classic example of a non-proprietary format would be like a CSV format because that's something you can open up in either Excel or just like any text editor. Um, Reproducible data cleaning. So again, this is the workflow that we saw. This is a slightly more realistic workflow, right? So your sponsor or your client is chances are they're going to be periodically like giving you more data, and sometime you need to like edit the data, like maybe discard some data. And this is also simplified. I mean, it can get even more complicated than that. Um, so it and we want to make sure that even in a complicated situation that it's still reproducible. So any steps that you do to your data, you want them to be very clearly documented. to make sure that anybody can repeat them. So another important point is that when you're writing code, like especially if you have like a code snippet that does some arbitrary change to the data that you felt was necessary for whatever reason, that you comment it heavily so that anyone who looks at the code is going to know like what you did and why you did it. So in this case, it says that yeah, like any blank values get replaced with like this string right here, and that is described that's described in that comment, right? So yeah, so anything you do, you always want to comment it. As far as methods go, so we're talking about like tools, software, algorithms, and scripts. Um, so whenever possible, we want to use open source or uh, like tools that are like ideally open source. Um, and obviously they should be well maintained and stable. So R and Python are both open source. These are actually some libraries that R programmers like to use for data processing. Uh, I mean, often like sometimes we're going to want to use proprietary tools like Excel, uh, MATLAB, or SAS is a like statistical package. But these are like very uh, like widely used, widely known tools, so that they're also pretty good. Backwards compatibility is a plus, right? So R, for example, if you take an R script that's uh, that was written for one of the previous versions of R, you will still be able to run it with the current version. That's what backwards compatible means. And yeah, so another advantage of scripts is they offer opportunities to document decisions and ensure that steps are taken exactly as described. So, I mean, they're gonna execute the same way every time. Uh, like I said, comments are always good. Reviewers can review the scripts and the results to understand the process, because I mean it's all just in the text. And of course it's important to record like the with like whatever version of software you're using, and like any packages. So speaking of version, Git is like the industry standard version control tool. So if y'all have ever heard of like GitHub or Bitbucket, those are both going to be based on Git, right? So essentially, like most developers would know what Git is, um, and it's important to use, because I mean, if you write a script, chances are it's going to evolve over time, and if at some point it like breaks, you want to be able to like revert to a previous version that was working, and that will also help you like debug and fix your problem. And also, if you have multiple researchers working on that script, then Git is also super helpful, kind of keeping track of who did what. Uh, so software portability is important. So like when someone sends you a script and asks you to run it, there's no guarantee that you'll be able to run it, because things like operating system issues and like file system discrepancies, like they can all like both those things can potentially interfere with your script running. So the way we achieve portability is we can either use uh, like a virtual machine, and popular virtual machine software is VirtualBox and VMware. Or we could also use a container, and like the industry standard for that is Docker. So a container is essentially like a lightweight like a lightweight virtual machine. I'm not going to go into like all the details. That's beyond the scope, but yeah, it is pretty heavily used for portability and for guaranteeing uh, that people can in most cases just pick up your script and run it without worrying about any like issues. Okay, analytical decisions. Um, so any like discretionary choices that you made should be documented. So like an incomplete list would be like if you perform say a dimensionality reduction in your data, such as like principal component analysis or something like that. Uh, you obviously want to document that really well. Model selection, right? So so let's say you're using like hypothetically like a language model to do some of your data processing. You obviously want to make it very clear which language model you're using. Choices for like thresholds, like which values you consider outliers and stuff like that. Um, and yeah, and in your documentation, you want to include like your statistical tests, any external references, and subject matter expert statements, just that kind of stuff. Uh, Analysis should be legible, right? So depending on what language, like let's say you're writing code, depending on what language you're programming in, there are various ways to make your code more legible. So in the R language, they have like this pipe operator, and that can sometimes that can sometimes make your code legible, as I'm about to demonstrate. So let's say you have something like this, right? This is not very legible because you have all these nested parentheses, which nobody likes. One thing that you can do to slightly improve it would be something like that, so you can kind of see like the structure and all that. But that still does not look ideal. You could do something like this, and that way you're kind of separating out each step in your code. Problem is that you're creating all these extra like intermediate variables. Um, so this is what would probably be your best choice here because looking at that, you can immediately see what's going on. So you have a little bunny. Uh, he hops through the forest. He scoops up field mice and he bops on his head. And you're saving that result to this variable right there. Um, so so this is just an example of how we can make source code look more legible. So yeah, so some more kind of like things to keep in mind. So you want to use descriptive variable names. So say you have a variable that stores say profits. You don't want to just name it P, right? You should probably name it like profit, because that's more obvious. Uh, as I mentioned earlier, excuse me, comments are important. White space whenever appropriate, wherever appropriate. So like blank lines sometimes help to like kind of separate like chunks of code. Comment your analysis. So another example of comments. Let's say you have an Excel spreadsheet. Uh, so let's say you're performing a complicated calculation such as a reliability calculation, and you're using all these math formulas and stuff. So someone who is not familiar with reliability calculation, if he were to look at this spreadsheet, he might not know like what to do with it. But if it's very heavily commented, like so, then someone who knows nothing about this can spend a few minutes reading it and figure it out, right? Yeah, so comments, color coding sometimes helps. In Excel, you can actually do something called conditional formatting. So like you can say, well, if a value is like less than this amount or greater than this amount. I want to make it a certain color. Okay. Using reproducible techniques for summarizing data. So I'm sure everyone here has used Excel, right? Who knows what Power Query is? Okay, so Power Query, it's a little bit of an advanced Excel tool that essentially lets you kind of like record the steps with which you manipulate like a table, and you can like rerun those steps anytime you want. So it can be pretty useful. It's sort of an alternative to writing like a Python or an R script, basically. So so let's say we have a situation where so we have this data right here, right? And let's say I want to calculate I want to calculate like the average launch time by light conditions and length, right? So I want to essentially take the average of like these numbers, right? Because it's the same light conditions and length. These numbers, and so on. How would I do that? So so yeah, so Excel Power Query has this nice little function called group by. So it will allow me to group the data by light and length conditions, and then I'll just give it the operation that I want to do, and it will generate this this column. So I can actually demonstrate that. All right. So first thing I'm going to do. So does everybody know what an Excel table is? Okay. First thing I'm going to do is I'm gonna highlight this data, and I'm going to hit Control T, or I can also hit Insert Table, and that will convert this range to a table. And let me see. I can actually unselect abandoned rows. Tables by themselves are actually super useful. So just in case anyone here has never used an Excel table, I would highly recommend you check it out, because like let's say for example I want to sort by this column, right? I can do say smallest to largest, for example, right? Let's say I want to like apply a filter, right? So numbers, say only greater than 15 or something. What? Filters greater than 15. Yeah. So yeah, so it only leaves numbers greater than 15. Let me go back. I should probably choose a different value. Hold on. I think I applied it to the wrong column. Greater than 15. There we go. So yeah, if you're not familiar with Excel tables, definitely check it out. And I might have actually opened the wrong Excel file. Let me open the correct one. Okay. Oops. Wait a second. Hold on. Be okay, yeah, that's fine. Okay, so I want to compute these averages, right? So how do I do it? So once I have my table, I'm going to go to data, data from table range. So I'm going to click on that, and that is going to open up. Yes, that's going to open up Power Query, and it's actually going to be a separate window. Okay, so then I'm going to go to transform, and I will click on group by. And I want to group by light and length. So I'm going to switch to advanced, add grouping, and I'll select length. And new column name, I mean something like average length or something. For the operation, I will be averaging it. And what column will I be averaging? Launch time. I should probably fix that. Average launch time. Okay. And there we go. There is my average launch time. And then I will go back to home and click on close and load. And it will create a separate, like a separate Excel sheet with what I want. So, like, any questions about that?
Is that still connected to your other sheet? Like if you change?
Yeah. Well, yeah. So this is the sheet that I was working out of, right? And it created this sheet. Does that answer your question?
So if you change something in sheet 1, it's still attached.
Oh yeah, you're saying if I change it, yeah, I may have to rerun it actually, but let's say I make this like 1,000 or something, right? Is that going to, yeah, I do need to actually like rerun it, but you know, for that I would just open up the I would open up the query. So the queries and connections is going to be here. Yeah, and as we can see, it generated this value right here. But yeah, so that's an example of Excel Power Query. Yeah, and like one last thing to note is that same results don't necessarily mean the same conclusions. So you know, two different people might look at the same result and they might conclude something different just based on their like background and expertise. Okay, so if y'all want, we can do a couple of exercises with Excel Power Query. The first exercise, we have data that is in this format right here, and we want to end up in this format. So we want to unpivot the data. So essentially, we want the like the weight and the number of passengers to be like separate columns, and these values right here are actually launch times. Um, so we want those to be in a separate column. So the way we're going to do that is by unpivoting the data. So pivoting means you go from like from this format to this format. Unpivoting means you go the other direction. And we're going to try to do that in Power Query. So I'm going to open, and I mean, y'all can follow along if you want. I'm going to open RHIB, the Excel version. Okay. And I'm going to, yeah, I'm going to select the data, insert table. Then I'm going to go to data, and I'm going to click from table / range. That will open the Excel Power Query prompt. And we want to unpivot these last 4 columns, right? Because we want to separate like the weight from the number of passengers, and also get an additional column for the launch time. So I'm going to select, excuse me, I'm going to select these 4 columns. Right click, and I'm just going to click on unpivot. And there we go. And it essentially did it for me. I still want, so anything else I should do to get from here to where I want to be? So this is where I want to be. This is where I'm currently at. What do y'all think the next step would be?
Split column 3.
Yep, split column 3. So I'm going to select column 3, right click, split column, split by delimiter, because I know exactly what I want to split by. It's just a dash. Split by delimiter. And yeah, so custom delimiter, dash, we'll hit OK. Anything else?
You name the columns.
I could name the columns, right? So what was the name here? Load, passengers, launch time, right? So right click, rename load. Right click, rename passengers. Right click, launch time. And maybe one more step.
It says 2 paths instead of the PDF.
Yeah. So right click, replace values, pass, and what will I replace it with? Nothing. Yeah. There we go. So then I'm going to hit close and load. And yeah, and there's my results. So let's say that I wanted to write this thing in Python instead of using a Power query. So, and let's say that I was not a very skilled Python programmer, which I'm technically like not really. Right? In that case, I would obviously use ChatGPT. And here's what I would say. I have data in the following formats. Let me actually open the CSV version. Oops. Yeah. I'm going to open that with, choose another app. I'll just open it with Notepad because it's a CSV. You can open it with anything. Copy, paste. I would like my data to be in the following format. Well, I would like to convert my data to the following format. And I will open up my other CSV. Oops. So let me actually save this to a CSV first. And click. Delete that sheet. Notepad. What am I doing? Save that as a CSV. Right click, open with, open. What? What was that?
There's a file above it that has the.
Oh yeah, my fault. Open with, Notepad. Copy that. Okay. I'm going to add in a file named rhib.csv. And save it to rhib_out.csv. Please write me a Python script that does this. And it will just generate all your code for you. So I'm not sure if this is correct, but we'll run it just to see what happens. So the other times I've tried it, it was able to it was able to get it right. I'm not sure why it's doing that. So let me go to CMD. I click new. I'm going to create a Python script. Paste. Oops. Oh, it's hiding the extensions, right? How do I fix that? I think it's view, show, extensions. Okay. Oh, Python's not found. Okay. Yeah, probably. Yeah, I mean, I don't know if I want to install Python right now, but maybe I can try to find a without an account. I mean, I do have an account. Yeah. About Python compiler online. The only thing is I'm not sure how it'll access the like the input file. So I mean, I can just probably have it store the input data in a table or something. Just kidding about the input file. I want that data to be stored in a, like in a string or something. I want the output to be printed without creating an output file.
Do you know, is it actually generating the code line by line and it's displaying it, or that's just purely for aesthetics?
I would think that it's generating it line by line. Because I mean, the way language models work is essentially given like a context of like n tokens, it's going to calculate the most probable like n+1 token. But I'm not 100% sure though. Okay, let's try that. Oh. Okay, data frame has no attribute append. So the nice thing about ChatGPT is you can actually give it the like the error, and it will attempt to fix it. So I'm just going to copy paste the error message. My apologies for the oversight. So yeah, sometimes it takes a few iterations.
Right. Well, I mean, it's also called pandas, so we could just know pandas data frame.
I mean, it is. I think it is converting it to a data frame, I believe, because yeah, it's saying like PD or pandas.read underscore CSV. So it's essentially treating the string as a basically a CSV file and reading it into a data frame. But okay, let's give that a shot. Oops. Run. Oh, there we go. Well, yeah. So ChatGPT is pretty good at generating code. I think at this point most developers probably use it to a certain extent. I mean, if you ever need to write like a very big like program, it probably makes sense to like write like a small piece at a time. I mean, just like you probably wouldn't write 10,000 lines of code before hitting the run button. I mean, you wouldn't expect ChatGPT to be able to do that. Okay, so that was the first exercise. And for the second exercise, oh, wait a second, I think I've been, oh yeah, this one now. For the second exercise, so we have this data, and we want to create a graph that looks like that. So we want to display it on a scatter plot, along with a trend line, and the equation and the r² value. So does everybody know how to do this in Excel? Cool. I mean, I'll do it anyways, just for the recording. So let me open this one. So I'm just going to select the whole thing. Insert, charts, scatter, and there's my scatter plot. And I'm going to click on one of the points, right click, add a trend line. I'll include the intercept and the equation. No, not set intercept. I need the equation and this is blocking something. There we go, the r² value. And that's pretty much it. And of course, I can always change like the axis title and stuff. So right click, I think is it format axis? Yeah, it's here. It's add chart elements and then axis titles. primary horizontal, primary vertical. Or I could get ChatGPT to write me a Python script that does this. But given the circumstances, I mean, normally when you want to visualize graphs that are generated by Python, you want to use something called Jupyter Notebook, which like works very well with Python, and you can essentially give it Python code, and like it'll it's a really good visualization tool. Problem is they don't have Python or Jupyter Notebook installed, so I guess y'all are just gonna have to take my word for it that ChatGPT was able to generate code to construct this graph. And any questions or comments?
At IDA, do you guys usually use like markdown files or Jupyter notebooks to do these types of things to keep the reproducibility?
Yeah, for like excuse me. So whenever you want to create like a lot of data visualizations, like graph charts, whatever, programmatically, Jupyter Notebook is like, I mean, I believe it's like the industry standard for accomplishing that in Python. So yeah, I think a lot of people use it.
So general comment, another question earlier was, are the tables connected? When you go to the query table in your new table, it actually has a refresh button. So if you update the table, you don't have to save it. You just hit the refresh in your new table and it will bring in the new information.
Okay. So if I go back,
or at least it worked on my computer. And not duplicate.
Yeah, for some reason, like I got it to work at some point. I'm not sure why it wasn't working this time. So you're saying that.
So in the data tab of the new table,
data.
There was there's data. Refresh all.
Refresh all. Oh, okay. Okay, I see. Okay.
It was bringing in the new
information. Okay. Yeah. Anything else?
Just for in general, also using the data model. If your data stored on any type of SQL or ODBC compliant database, you can link it that way as well.
Yeah, I noticed there was a so you're talking about get data from database, right? Yeah.
No questions in the chat, so.
Cool.
More general question.
Yeah.
So at least in my group, like we have a lot of experimental data and we cannot seem to come to an agreement on how to name our files and how to like store our metadata. So I was just wondering if you have any like recommendations or on industry standards or like.
Well, for naming files, I mean, I don't know if they're, I mean, I'm not sure if there are industry standards for that. But I guess that goes back to my comments about like the slide that says that you want to make your variable names descriptive, like when you're writing code. So, I mean, I usually try to make my file names descriptive, just so that like when I look at it 6 months from now, that it's gonna like ring a bell, right? I mean, if the date's important, I might start off with something like 2024-04-17, like underscore whatever, right? And if there's like a version or something, I might end it with like underscore like v3.5 or whatever the case might be.
And it's good to have a readme somewhere that says this is the policy, this is the format, so that everyone follows it, because everyone has that problem.
Set your own nomenclature and just put it in the readme. Yeah. And then you can shame people who don't follow.
Reject.
Or if you're like a project leader, then I mean, you can like tell your team members what nomenclature format you want them to follow.
I think we have this data management practice now. Basically, within a project, you're supposed to establish a standard, and then I don't want to paraphrase the standard badly, but there's a practice to follow here. I don't know how widely it's being followed yet, but it rolled out a year or two ago. And yeah, each project is supposed to have their own standard and then follow it for consistency. And have a README at the top level.
And it's easy to write a Python script to organize it once. You know, if you have someone's been doing it in a certain format and for a while, you can just run a script and read them, reformat, split, you know, drop, all those little things, clean it up nicely.
Called a linter, right?
Linter is, we use linter. Is that integrated into? Do you read that into Python?
Yeah, I think that's what it does.
Yeah, it might be that one. But I think like split and these come with just maybe the basic thing or something else. I'm just doing the fundamentals.
I like to name all my files final underscore really final.
Almost final. No, this one is the last one. Mine is like mostly junk, it's more recent junk, yes, miscellaneous.
S1, 2, and 3.
Doesn't help even a couple months later.
No further questions. We can thank our speaker.